Welcome to my documentary of atrocious squat technique. Absolutely atrocious. Just kidding, guys. I'm going to make an anvil out of a railroad track. So railroad track material is about 1084, the steel type, 1084. That's got 84 carbon points, quote unquote. And the max carbon you'll see in most of these steels is 1%. So, 84 would be like 0.84% carbon content. So carbon has a great effect of steel, even in moderate percentages. Railroad track commonly has manganese in it too. Manganese improves several qualities, and it allows the surface hardness to be to a greater depth. So it enhances the depth to which the surface hardness can be achieved. It also increases the abrasion resistance, and there's some other mechanical properties manganese does too. But railroad track, that's the two principal alloys. It's 1084 with manganese. You can see this a little bit of a misshapen profile on this railroad track. This railroad track is commonly referred to as 40 pound. Railroad track is classified in how many pounds per foot of track. There's 40, 50, 80, 130, 90 maybe, I think. I've read a bunch of different documentation on this, but this railroad track is approximately 40 pounds per foot, and I think I have about a 14 or 15 inch long piece here. This railroad track still had moss growing on it when I got it, so there was the emblem Colorado kind of stamped on the side of this anvil, and I actually wasn't paying attention. I cut that in half, and so you'll see later on in the video I kind of cut that in half. I should have kept the Colorado intact across the side. It would increase the aesthetic, but I usually leap before I look. It's a personality flaw, but I'm in counseling for that, so don't you guys worry. So here I am marking out. This is going to bolt. I'm going to make a stand. Now this is going to be modular. I want to be able to unbolt this anvil and put a different. I have about 10 feet of this track material, so I'm going to make different anvils for different purposes. The purpose of this anvil is for straightening knife blanks. That's its purpose. So I just want something long and flat that I'm going to machine very flat, and I can hammer out. And from my forging operations, sometimes there's some cupping that occurs in the billets, and there's some twists. So this is going to be purely used just to flatten out and straighten some of my Damascus billets that I forged. So the shape isn't a very traditional anvil shape. I know I'm deviating from a lot of norms here, and some purists will say get a real anvil, and to them I say meet me out back for some unarmed combat. I'm ready anytime you are. So I didn't have the money or the time. There is some good deals on anvils you can find, and I did look into it. I just needed this now, and so it took me a Saturday. I made this whole thing in a Saturday, so it was pretty effective use of my time. I needed it. I made it. I have it. So I didn't have time to go, scour the internet and Craigslist looking for a good deal on an anvil. I had this track. I made it work. So here's the shape. Now there's all kinds of different anvil shapes, and there's a huge, this shape anvil's better for this, and this shape anvil is better for that, and there's all different kinds. There's a hardy hole, which I will eventually drill a little hole in this that you can slide tools, like a hot cut tool, and different dies for different shapes, and you just have a little square hole in the top of the anvil, and then you have different pre-made little tools you can drop in and to do different things. So I will eventually have that in this, and I could have welded two of these tracks together and doubled the thickness of the top of this, but I might do that on a different when I have lots of this track. I might do it, but you can see I'm running a 3/4 inch bit now. I'm drilling these corners out. It's much easier to drill these out when you're milling them or cutting them. But so I drill all 4 of these corners out, and I got the speed. I'm using oil. It's a 3/4 inch bit. I got the speed dialed in just right. I'm making some pretty good chips coming off of this guy. Now you can tell as you're drilling through this. Initially, you can see the chips. They're smaller. the surface hardness of this rail was actually pretty good. Once you got through it, though, you could tell as you're drilling, you can tell the steel's getting softer as you get towards that core. The interstitial layers of the steel are softer, and that's usually beneficial. Now think about it: if a steel is really hard, it's prone to fracturing, it's prone to cracking. Cracks can propagate easier in material that has a high hardness. So really the goal on a lot of steel is a balance. You want a good surface hardness, but then you want a ductile core. So the ductile core is going to be flexible, it's going to handle, it's going to have high shock resistance, right? And then you have a high surface hardness, and then it has that abrasion resistance. It's a good, that's the combination, and that's the whole thing with heat treating and conditioning steel, and is to get a good surface hardness, but have a flexible and ductile core. And this is all application driven, right? You probably want this combination of hardness and ductility for this steel. If it's a stamping die, you want this, and if it's an axle, you want this. Everything's a balance, guys. All this, anything with steel, it's all a balance of properties. You increase its hardness, it becomes more brittle, right? It's prone to fractures. You get really things that are really ductile, then it's prone to deformation and mushrooming, and so everything's a balance. So, but I drilled these holes out. This went pretty quick, and then I'm gonna use a combination. I don't show the cutting disc. I cut some of these out with a cutting disc, and these little reliefs on the end. And some of them I mill out because I was kind of looking for a little bit of a better finish. And I hit all these cuts. Once I'm done here, I hit everything with the flap disc, and I kind of clean up that. And then that top I hit with a flap disc where it bevels, and I get that. But I got my speeds dialed in here. I'm making some really good chips, and so. Maybe it's the OCD part of me, but when I'm looking at the steel and I'm seeing it machined, I see all these chips. A lot of times, man, when I'm done milling something, there's a massive pile of chips, and I sweep them up and I dispose of them. But sometimes I look at it and it's a waste. I'm like, man, look at all this metal. It's a huge pile of metal. It's got to be something I could do with it. And I thought about actually making some canister Damascus out of these chips, but that's a topic for a different video, I think. And so. But here I am fly cutting this. I tried using a cobalt fly cutter and a high-speed steel. It wasn't doing it. So this cutter here has indexable carbide bits, little triangular inserts that this cutter has, and that did the trick. I got some pretty good speeds and feeds. I almost got a mirror finish on this. You could tell my speeds weren't quite right. But if I would have got this dialed in, it would be a mirror across the top of that. And actually, one of the first passes, I did have it dialed in just right. I have a power feed in this, and I had the speed dialed in just right, and it was just giving me a mirror finish. But this is fine. It's an Anvil. I'm not going to be checking my hairstyle, what's left of my hair, in this thing or not. It doesn't have to be a mirror. It just has to be flat and relatively smooth. So here I'm milling out the ends of this. And I'm kind of profiling the underside of that a little bit. Now I flip this over. After that's all done, I flip this over, and I drill some holes in this base. And like I said before, this anvil, I'm going to make a stand for this. This anvil is going to be modular. It's going to bolt to a base plate that's on a stand. And then I'm going to be able to have other anvils that I'm going to make out of railroad track for different profiles and different operations. And so, in a small little garage like this, sometimes you have to make things modular, right? I don't have room for, a bunch of tools, and everything's got to be able to fit underneath the bench, and it's just a constant dance of trying to, manage space. My hope with this channel, guys, this is my sincere hope. This channel is successful enough, and I will actually get a large shop where I can have some of the bigger CNC equipment that I want to build, and I can have some of the sheet metal tools I want, and I can have a lot more. I'm running out of space in this. I have a power hammer for blacksmithing. I'm going to build in an upcoming video, and I have all the steel, and I have all the bearings and the motor and all the stuff, and I'm just looking around in my garage. I'm like, where am I going to put this thing? And it's just a constant battle of you know, uh, economy of space, and you know, I just want to build tools. I love building tools. I built my own CNC plasma table. I built my own 40-ton hydraulic forge press. I built my own little furnace. I'm building a power hammer. Uh, I have a design for a rifling machine to make my own barrels, and that'll be hydraulically powered. But uh, I'm just running out of room, uh, and so I'm just running out of room, guys. But hopefully, if this channel grows enough, I'm actually willing to relocate for the purpose of the channel. This may sound a little bit corny. I want to create content that people will enjoy. I want to make that, and it's something that I feel passionate about. It's something that I feel this, I've just put out a few videos. I don't have a lot of videos, but I feel just a lot. I feel a connection when people watch my video and they enjoy it, and it's something I really didn't anticipate liking as much as I do. But anyway, that's my hope. But here is, I'm cutting that. I just took a cut-off wheel and I cut this profile in. Now this is a little rough here. I clean this up with a flap disc, and now if you look at the top of the anvil, one side is square and sharp, and the other side I left rounded. The sides of the top. See, this side has been machined square, and the other side is kind of rounded. That's intentional. So here's the stand. Now, some of this is not ideal. I should have had like 1/2-inch plate or 1/4-inch plate for the base, but all I had was this section of concrete saw blade, which is about 0.187. So that's 3/16. And so I cut the top plate and the bottom plate out of this 3/16 saw blade. Now, the tube is 4-inch by 6-inch by 1/4-inch wall thickness. That's that tube. Now the height. If you want to ask yourself, I heard this from a very wise blacksmith. He told me that if you're standing next to the anvil with your hands relaxed at your sides, that your thumb should be about the height of the top of the anvil. Okay? And that's how I judged how high to make this. When I stood next to it, I'm 6'6", so it might be a little taller than for someone else, but when my hands relaxed, my thumb is right about even with the top of this. So this is it. Now I'm going to do some welds on this. This is just a general fit up, but and these are 1/2-inch holes that will bolt to that plate, and then I'm going to anchor the base to the floor with some recessed anchors in this concrete. So here I'm just going to run some tacks, and I had to tack this up. This base plate was thinner than I like. I usually go with 1/4-inch for a base plate, and I tried to do 1/2-inch, but once again, I didn't have that on hand. I needed this up. I needed to straighten out some of these billets, so I went with what I had. And so, but anyway, here I am test fitting this up, getting it all fit up, and that's most of these projects. The real value in this, guys, and if you're out there grinding away in your own garage and trying to make something, it's about doing the most with what you have. That's the real genius of economy, the real genius of innovation and adaptability, is to do the most with what you have. If with a fully equipped machine shop you could make anything to your heart's desire, what can you do with the minimum? And that's really the judge of someone who's highly skilled. That's the metric why I would judge that person as, what can they do? It's about doing the most with what you have, and that creativity. And that's what really drives a lot of innovation. Now, I'm using these bolts. Now, I identified a little weakness here. You can see a lot of this, I design it as I go. There's no set of plans for this, right? I'm making it up as I go along. Now, I'm like, one of those bolts in the anchor just wasn't enough, so I had to put an anchor in on the other side. And then the tube itself wasn't that rigid, where how it connected to the base plate and how it connected to the other plate. And so I drew some gussets here, or brackets, or braces, I don't know what you want to call them, but I drew them out of my plasma real quick, very simple. I cut them out of the same plate. Now I was really surprised. Once these were welded in place, and I didn't go crazy on these welds, I ran these little 1-inch beads here and there to connect these plates together. And I was really surprised with the rigidity increase. And that's the real trick in engineering anything. It's about doing the most with the least. You know, I could have made this thing, I could have got like, an 8-inch by 8-inch square tube with 1/2-inch wall thickness and 1-inch plate for the base plate, and or mounted the thing on a huge log or something. But this turned out to be very rigid without having a lot of steel. Now, people that are very adept in metalworking will tell you that the weight of the anvil is very important. The mass for all these other properties. There's a lot of physical properties that anvil have, and you'll see people will wrap chain around the base of the anvil. And some of that is I think, to get rid of some of the resonance that occurs when you're hammering it. But a lot of these bases are designed just to be heavy. It's about having a solid, heavy base, and that's what a lot of anvils are. People go nuts over these anvils. It's practically a cult. You start talking to someone about anvils, they start foaming at the mouth, talking about, one of 5 anvils that were made in Finland that, someone found in a farmhouse and enshrined the thing and started worshiping it or something. Some of these people are cultish with how fanatical they are about these anvils, but, they would turn their nose down at using a railroad track for an anvil. They'd scoff at it. But once again, everything I do, guys, is utilitarian. This is something someone with a grinder could make in their garage. You don't need a lot of fancy equipment. This is very basic stuff. A grinder, a drill, some cutting discs, a flap disc. So here it is. It's all tacked up. Well, not tacked up. I stitch welded it. This is with 2 anchors. This is very rigid, guys. This is very rigid. It came out perfect. I'm really happy with it. Now, I did clean this with some acetone. I threw some paint on it, only because I might bolt this outside. I have a slab on the side of my house, and I might have this bolted outside. So I wanted to throw some paint on it just so it didn't rust up. And so I used this Rust-Oleum blue. It's it's paint and primer, and you can paint to mill scale. It sticks excellent adhesion to mill scale, and so I didn't have to grind it off. I just had to clean it with some acetone. And there's the Colorado I cut off like an idiot. And then I used high temp black on the anvil. But this is it, guys. It came out really nice. It's very rigid. And you can see here, I'll throw some tests on there. It's supposed to bounce. When you have a hammer hit an anvil, it's almost supposed to bounce off. It's all right. This is a heavier hammer. It's all right. I mean, like I said, this is very purpose driven. This is a very narrow purpose I have for this. And I'm going to be basically using it to straighten out these knife blanks, and you'll see. Now, this bounces pretty good. I think this is a better hammer. So these are pretty good hammers I have. And I have some blacksmithing hammers I'm forging, actually. And I don't have it in this video, but I have some Damascus hammers I've made. And I don't have handles in them yet or nothing. And I have a whole other video of that. I haven't put it up yet. But you can see here, all I'm going to do this billet was drawn out, and my dies on my forge press put a little twist. The whole billet was twisted, and then there was a slight cupping. There was a slight cupping to it too. So I'm going to actually be grinding this blank out into several knives. There's going to be some knife projects I'm doing. I think this is 30 layer, I think, or 25 layer. You can't tell, and it's just covered in scale, but there's a bunch of layers in there. This is Damascus, so there was a lot of twist induced in this. So you can see I'm taking it out, I'm flattening it out, I'm sighting down it, and testing out this anvil. It works very well for the anvil's ground, very flat. It's perfect for flattening out knife blanks that I'm going to grind down. I'll work into a project. So I think this is my second heat. I only did like 2 or 3 heats to straighten this out. And so props to my daughter Maddie for getting some of these shots for me. It's hard to shoot with a GoPro while you're carrying around glowing chunks of steel, but here it is, guys. This came out really good. I'm flattening this out. I'm working with some of the um, um, uh, some of these ridges here. I'm kind of correcting a little bit, and I'm flattening this out and straightening it out. So it's for its intended purpose. It came out perfect. The only thing is that the top's a little narrow. I think I might actually make another one where I weld 2 of the tops together to double that surface area on top there, make it a little wider. But for the little knife blanks I make, this is perfect. And like I said, you can see in the back there, behind in the background, I have another 6-7 feet of this stuff, maybe more than that. I'm gonna make some different anvils. I can unbolt this and bolt another one on, and this bolts to the floor with 2 little nuts, and I can take those little threaded rods out. I can slide this under my bench. I can slide it out of the way. So it's very handy. It's very modular. So I'm really happy with this, guys. Thank you for watching this. I appreciate your time. You guys stay safe out there, and look forward to making some more video for you guys. And thank you, guys.